One of the other functions I really wanted to get into is find, which is a search function, which is critically important when it comes to strings, because in my educational examples that I'm giving here, they're just one words, but these could be massive, collections of words, a book, a poem, just regular straight up data. They're going to have spaces in there. They're going to have exclamation points. They're going to have punctuality on it. All these, punctuality. Whew. Anyway, these are going to be much larger than the simple examples that I'm giving you, but that's how important these particularly two functions are. There is two versions of this, and they both work exactly the same, except for find finds the first occurrence, and our find will find the last occurrence. That's the only difference. Otherwise than that, the overall setup of how this works out rings true. Now, with that said, we're going to find an OLI. What it'll do is it'll find the OLI and return the index number back to us. Now, notice, by the way, I did have to convert it back to an int if I wanted to store it as an int for the index number. Otherwise, it's going to return a size t. So just a heads up on that. You've seen this example already. There's two versions even of the parameter setup. Here, it's looking for a p, but I want you to start at index number 4. Okay? Again, that'll return an index number of 5, I believe, in that example. Okay? So again, two different versions of, there's many different versions of find, but there is a mirror version of the same thing for our find, starting from the rear and going forward to find exactly what you're asking for. In the previous examples I was showing you, there was a match found, and the value was always something either 0 or greater because it did find a spot where there was a match. But what happens if there isn't a match? What I had to go back to is and look at some details of find to reveal that there were some interesting features. First of all is that the actual function returns a size t, which is, well, you know what size t should be now. It's 0 and greater. If the size t value is greater, that should be greater with the ER, than the string size, then we never found a match. And that's coming from that C++.com thing that we were talking about earlier. And what do I even mean by that? Here's an example. String text, Professor Lupoli loves his job. I'm going to try to find Lupoli, and I'm going to display that. I'm going to try to find hate, which, by the way, never shows up. So if we look at it, and when we're trying to find Lupoli, it tells me it's index 6. Okay, so P is 0, 1, 2, 3, 4, 5, and 6. Yep, there's the L. For the hate, which is not there, it returned that. That's a heck of a lot bigger than the string length, which I'm going to say is about 20-some, something like that. That's a heck of a lot bigger, isn't it? So that's quite interesting that's going to return that. But you're going to see a lot of people do this. Instead, excuse me, what I'm going to do is I'm going to text.find Lupoli. I'm going to put it into an integer called pos, or position. I'm going to go ahead and display the pos, finding me, and you know it's going to find it at 6. But then I'm going to do it again and put it back into that same integer variable, and this time hate. And instead of having this long, crazy number, it gives us a -1 instead. And that is not by coinkydink. Think about it. Remember, if it was 0, the answer was 0, that means it was the first letter in our string that we found a match. So I can't use 0. But I can use -1, right? -1 is not a possibility or not an element or index location for a string, so I can get away with using -1 if I convert it into an integer like I did here. And that's also much easier to frankly deal with than maybe size of the string or anything else, like, because this numbers could be random. Frankly, it's just going to be larger than what your string size was. So just a little food for thought for that. Now, the last two questions here. What would the index be returned for the function call lollipop.rearFind of L? And we start at index number 1. So for lollipop index starting at 1, I'd move over, starting from the rear, we're going this way. So that would return 0 because my next available L is at index 0. So again, 0 is a legitimate value. That means the first index, just like an array, in a string. Same idea. All right, What if I did lollipop R find and I had no setting on exactly where to start from? So I'd start all the way from the rear, and I would go ahead and search and try for my first L. There it is at index 3. So we'll return a 3. So that's our interesting find with find.